Hi and welcome to part 2. Hopefully I'll call it the second half, but if it doesn't end up being the second half and it goes on a bit, then there's going to be a part 3. Well, this is the code where we left it off from part 1. I have made a small change in here. It will not affect you. It's just the coordinates of where I'm going to do my tool change. I've changed them to suit my machine, so you just need to set them what is suitable for you. So we need to get a few coordinates off of our machine now, especially for the Z-axis. So I've moved mine across to my new position and put my touch plate. It's all I've done is moved it from the right hand side to the left hand side. I'm right-handed, so it's easier for me to undo that nut with the right hand. That's the only reason why I've done it. So what I'm going to do is I'm going to take the bit out of the machine and I'm going to change it with the smallest bit that I've got so I can put it in backwards. Yay, I've tried with my left hand. It was quite simple. So what am I looking for here? So back in Mach4, if you look just above the Auto Tool 0, there's a little bit here that says guess length. Well, every time I do a tool change, I don't want to guess the length. Whether that works if you go in and if this sets it up per tool, I don't know, but like I say, I don't want to guess that length. So I'm going to set this up so it will do that guess length for me. That tiny little bit stuck out the bottom of the spindle at the moment, that is my guess length. So what I'm going to do, I'm going to go into the machine diagnostics. I'm going to need to get a coordinate off the Z-axis, and it needs to be absolute machine coordinates. So I'm going to reference the Z, and then I'm going to drop it back down to near the touch plate itself. That'll do me about there. Now with the touch plate and everything set up, we're going to use the MDI box here, and we're going to give it a code of G91 to go to incremental distance, and then give it our probing code of G31, and we're going to take the Z down in -2 steps, and of course the feed rate, I'm just going to take that down 25 centimeters a minute. So I'll do an execute MDI to get our probe touching. That's it, we're touched there. Now the coordinates I need are the machine coordinates here. We've got 54.7, so I'm going to call this 55. So what are we going to do with this -55? Well, if we pull up the script again that we was writing, we're going to set another local variable underneath the Mach instance. I'm going to put in a local variable of, I'm just going to call it guess len, and that is equal, oops, that's a plus, that is equal to 55.00. In fact, it's not 55, it's -55. So that's the first one we got there. Now we need another variable that we're going to put in here of our tool length. We're going to need to get our tool length now, and on the crest spindle that I'm using with collets, I tend to put the bit into the collet, and then with a permanent marker I'll just mark the top there so I know each time I put that in and put it up to that mark, it's going to be roughly in the same spot every time. Now the length we need here is from the collet itself to the bottom of the bit, which in this case I'm going to call it 25. So it's a 25mm tool bit I'm using here. Back in Mach4, we're now going to go and open up the tool table that comes with Mach4. I'm going to input the length there. That's my 25mm in the tool, just there. That's all we need, just quit out of that. With the tool table, you don't have to shut down Mach4 and open it back up like I originally thought. It's there, it's saved it already within the instance that you're working in. So let's get that information into Mach4, which is going to be our first part of our first reference point. So we're going to have to reference the current tool. We will need the variable of what the current tool is. So the variable for this will have to go underneath the current tool, and is what we're going to do is make another variable called tool length, and that's going to equal to get the data out of that table. Now is we're going to use MC tool get data, put in our instance. Now the command, well not command, but the variable we need from Mach4 there, if you go into your API, we're going to be getting the mtool mil height. I'm going to copy that across to Mac and put it in. If you leave that like that, that will now give you an error. You need to insert in the front of it an MC dot, which is telling Mac to get the number of it. We need to tell it now what tool we're getting, what mil height we're getting of that tool, from what tool. It's a teeth time again, which is the current tool of this one. We can now close that off. More variable times. We're going to stick in a local probe start is equal to our guess length plus our tool length. So we've got our guess length, which is minus, well, my machine was minus 55, but we need to put the tool in there as well, which was 25mm. So it's taken the 25mm, the minus 55, and added 25 to it. Yes, it will go backwards and the number go down because we're going in the plus direction. So we press F5 now to start off the debugger and jump through our script. So we're getting the local instance 0, our guess length of minus 55, our selected tool, which is actually 1 at the moment because it's got nothing telling it to do. The current tool is number 1. The tool length is going to our tool table and getting our tool length, and then we're doing the probe start, which is equal to the guess length plus tool length. So if you highlight your probe start, we've now got a minus 30. So this is going to send our machine to minus 30 before it does the probe start. So we press Shift F5 out of there at the moment. So now we can put the spindle into a spot ready to do the probing. That needs to go before the local change 2 because we want to do this probing before we change the tool. So we're going to copy and paste or type it out, whichever you prefer. I just get lazy. We're going to move our Z axis We're going to take the 0 out and we're going to change that Z. We're going to add our variable of probe start. That will then move our Z axis to the -30 position according to my calculations. I'm just going to put a couple of enters in there just so we split the scripts up. So we can save out of this, click yes, and you now need to exit out of Mach4, re-reference your machine, home all your access, and then we'll start the command again. So I've saved my M6 command, I've shut Mach4 down and restarted it. I've referenced all the axis home and I've set it up in a fictitious spot. And what I'm going to do is now go to an MDI and tell it we want to change to tool number 2. If I do a T2 M6, in fact press cycle start, not enter, we'll move our Z axis into a safe spot to the coordinates we set, and then it'll move down to our probe start precision. And judging by the height there, I never really thought about it much when I put the bit in at the beginning. It's a bit conservative, I can actually go down a lot lower than that. But I can change my 55 and keep changing it until I get to a comfortable spot. So that's how far we've got in the script so far. So now is what we need to do is add the probing section to it and get a reference point, our first reference point for our tool. Back in Mach4, in our M6 script, we can now start off the probing sequence to get our first reference point. So to move the machine, as before, we're going to do an MC control G code execute wait. Got a bit blank there, I did. And pass it our instance. The code we're going to execute is going to be the same as we done the probe at the beginning, just to get our guess length, which was our G91, then across to a G31. Now I've measured the distance between that to see what I had at the time, and there's actually 12 mil there. So I'm going to tell my machine it's actually -15 that I can probe to. Again, with the feed rate of 25. The Z -15, your feed rate, things like that you can change to your own specifications later on. Once you fine tuning, if you want to call it that. This now we have probed to our setting tool. You know, I totally went blank here. I can't think what to call it. If it's right or not, I don't know. Must be getting tired. Right, on the next line, we're going to get the reference now of the end of our tool. We're going to do this by setting another variable. I'm going to call this local tool Z, and that's going to be equal to an MC command of MC axis get position. It's going to be our instance number, that's normal, and we need the axis number of the Z. Mine's number 2. You need to check yours first to make sure which one it is, but my axis number is 2 for my Z. That is now going to record our Z exactly where the bottom of our tool is. So we can now copy and paste from the top here. I'll be lazy again as normal and drop it in there. Because we've got our reference point, we can now take our spindle into the spot where we can change the tool. So we can bring this back up there now, because we need to run that. So everything should be fine down to that point there. Something I've just spotted that could be a bit disastrous. You'll notice there's a little pink highlighted box up here. That's because I've not closed off our speech mark. So Mac wouldn't have run that line at all. So I put a speech mark in, it closes it off. That's fine again now. So we've changed our tool now to the next one that the message box asked us. Now our current tool is wrong, our tool length is wrong, and obviously our probe start is now wrong. So let's just correct them, and we can do that by saying that our current tool is equal to our selected tool. And our tool length is equal to the same as we got here. Just stick that back down there. And again, our probe start is equal to that. So once again, let's do a little bit of copy and pasting. Let's take the command we had here. In fact, we can take the next line as well. Copy that and paste it back down the bottom. So this should put us in our probing position and go to our next reference. So that's our second probing done. To get the references correct is what we need to do now is we're going to use an mc.mc. We'll use the axis set what was it, precision. Our instance axis 2, and is what we're going to pass across to that is what we got from our first reference point, which was tool Z, and then close it off. Again, we can now take our tool back to the 0 position. It's now ready to go back to the original coordinates it came from. But where did it come from originally? At the top of the script, let's do a x start, local x start equals the same as we did with the tool Z, which is this one here. Let's get the precision of that. That's the X, so that's going to be my axis 0. And then we'll do the same for the Y. Mine's number 1 for there. So we've now got the start position excuse me, before the machine starts moving. We don't need the Z at all, because you don't want to send your Z back to where it was. Your machine code, your G code will sort that bit out for you. You just want to get the tool changed. Now on the bottom, at the end of your code, we can do a straightforward mc.mc control. Control, that's right. G code execute wait. Our instance. Lost me keys here. Yep, there you are. You can tell I'm getting tired, and it's only 6:30 here. We're going to do a G90, a G0, and we're going to send that to our X. We need to close it off now because we're going to insert our X is going to be our X start. Again, we won't do that, we'll put 2 dots. We'll open it back up and we'll do our Y, which will be our Y start. And then we can close it off. Remembering to change that, I'll put it twice, and that's nearly about it. One other thing you're going to need to do in here is at the end is we're going to need to set our current tool because we've changed it. So we'll use an mc.mc tool command, and we'll use the set current. Now we're going to set our current tool of the instance to our current tool. No, it's not, it's our selected tool. To our selected tool, that one is. So, quick save, press F7, no errors apparently. So once again we'll close everything down, shut Mach4 down and start it back up so it recompiles the M6 code for you, and I'll do a quick run of it on my machine to see what happens. Now as a test, I've started up Mach4 and I've again put my axis in a fictitious spot. I've got into the tool table and I'm using tool number 2 now, which is that little dumpy thing. It's only 15mm. So I'm going to change the 15mm. I set it on top, that its 0 is sitting on top of that plate. Cut that out. I'm on tool number 2, so I'm going to do a command of T1 M6, so it tells it to change to tool number 1. Do a cycle start. Again, it's going to go to 0, move to our tool change position. It will set itself up for the probe start and then do the probing. That's the probe finish, and we'll now need to put our tool number 1 in. And we'll click, oh, what's happened to that box? We'll click OK. That's probably something to do with Camtasia running in the background. Again, we're setting up our probe start. Searching for our next reference. Back to 0. That's our tool change finished. I'm going to send, this is a longer tool. Now if this is wrong, and don't forget this is going to push that tool straight through the vise, or try to, it'll just make a mess. So I'm going to send my Z axis to 1, which is going to be just above it. So I've got that. What I'm going to do is I'm going to do a probe now. Put that bit back in that I had there. We'll be probe onto this one. Press cycle start. We've stopped there. We've got to 0.03 of a millimetre. Not 0.3 of a millimetre, it's 0.03 of a millimetre. That's pretty close to me using the Mach4 DROs, but we're not finished yet. Well, unfortunately, I've just checked the timeline in Camtasia Studio and we're just underneath 30 minutes again and still got a fair bit to do, setting some fail safes within the function. I've still got to compile all this obviously and upload it, which is going to take quite a few hours, so we're going to have to run into part 3. So until part 3, get writing the code that's already there.